Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to talk about CPK. And someone's asked me, CPK for all critical dimensions. So it's a comment that's been left on one of my videos. So I've got a video out there, I'll leave a link at the bottom here. Got a video out there that explains CP, CPK, sigma level, all sorts of different capability statistics. And then what he said is, well, that's fine for individual dimensions, but how about one for all of them together? And I've been asked this question before, which is that can we work out CPK for all the critical dimensions all in one CPK number? And the answer is no. There is no CPK where you can put all the dimensions, all the data, all in one place and calculate the CPK in that way. And even if you could, what's the next question you would ask? And you've got your process here. What is it that you want to do? Well, your process, it makes money. You've got inputs. You've got inputs, and of course you've got your outputs. Let's say we have three critical dimensions. Dimension A, dimension B, dimension C, and this is this is a machining process. So this is speed, feed, maybe it's material selection, tip choice, maybe it's cleaning the filter out. Just an example of what the variables might be on a machining process. Now let's say we found out some clever way of putting all of this data all together. I mean, one thing you could do, if you wanted to do it, you could reference everything on a Z scale. You could do it this way. You could reference everything to the Z scale, how much deviation it is from the center of the Z scale. The center of the Z scale, of course, being 0. And you could do some fancy statistical calculation, and you would jumble it all up and you'd put it all into one CPK calculation. Let's say you got a CPK that looked like this. So you got a CPK that was at, let's say it was at 0.93. If you did that and you said, well, now I've got a problem. Well, what's the next question you'd ask? Well, the next question you'd ask is, yeah, which dimension's giving me the problem? Is it A, B, or C? And so what you'd then do is you'd then look at the individual CPKs. You'd look at the individual CPKs of the three critical dimensions, and you'd say, it looks like B and C are my problem, and I'd go and fix them. Well, that's what you'd do anyway. Why don't you just work out the three CPKs for the three critical dimensions? Because these tolerances could be wider, they could be narrower. So you've got the situation that the tolerances aren't necessarily the same. The tolerances might not even be in the same units. So if dimension A, for instance, happens to be a size, that's fantastic. But what happens if one is a bore, one is an outside diameter? It's completely different potentially. Maybe one is the surface finish. So now we're measuring in a completely different set of units. So sometimes, you know, if we try and combine all the critical dimensions, I mean, one of them could be an angle. I mean, that is a dimension in itself, but what's the angle of a particular face that you've machined? You see that we're now in different units as well as different, you've got different tolerances here going on, and then of course you've got different settings. So in order to fix the problem with B and C, maybe you've got different variables that you've got to play with. A dimension is effectively a different process. You have to have rules about what tip you choose. You have to have rules about how often you change it. You have to have rules about what speed and feed you run when you're machining that particular feature. And it might be completely different for dimension A than dimension B and dimension C. CPKs are individual and can only be dealt with individually. You could do something fancy with the Z scale if you wanted to. That would put them all together, but then the first thing you'd do when you had a CPK that wasn't very good, you'd take them all apart and you look at them individually. And that's what people do. I've seen people with 50 CPKs on a really complex component that goes into an aero engine, and they literally worked out 50 CPKs, 30 pieces. They measured all the critical dimension on those 30 pieces. They worked out all the CPK values, and then they worked on the ones that gave them a problem. So there is no way of putting CPK into one number, and even if there was, you wouldn't want to do it anyway, because you'd want to know which ones are giving you a problem. So in answer to your question, and I will send you the link, unfortunately, CPK, it's an individual value for an individual dimension.